Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Syaqinah Binti Rahman. Today, my group and I want to introduce about two-stage air compressor.
So this is the team consisting of five people. That is Siti Nur Syahirah Binti Yahayah, Siti Syaqinah Binti Rahman, Syaqif Harraz Deen, Ahmad Muhsin bin Sazali, and Siti Nur Fareha Binti Muhammad Jailani.
Okay, so an air compressor uses an electric motor to convert the electrical energy into mechanical energy, converted to thermodynamic energy in the form of compressed air. It is the it is the utilized to rise the pressure of a volume of air. And design use at least the basic principle, which is staging, intercooling, compressor displacement, and volumetric efficiency. Compressors are staged to reduce the temperature rise and improve compression efficiency. The temperature of the air leaving each stage is cool before entering the next phase.
For this part, we will delve into the procedure and how the experiment is done.
Okay, so this is a procedure of experiment two-stage air compressor. So firstly, ensure the cooling water flow rate is sufficient, approximately 100 liter per hour. Adjust using the valve. Then connect the water inlet and outlet properly. Then plug the flexible cable into diagram D1 for compressing air at P4 is equal to 2.5 bar absolute. Then start the air compressor by turning main switch on the control panel. Then record the data for suction condition into the table datasheet. Then wait for 10 minutes to get a steady state condition. Next, record the temperature and pressure value indicated in the column for stage compression of the datasheet and wait for 5 minutes. Fill up the values in the second state of the compression column and wait 5 minutes for the final compression. Then, record the rest of the data in the datasheet. Repeat the step A until G for P4 is equal to 4 bar and P4 is equal to 7 bar absolute by replacing the cable flexible into diagram D1 and D2.
Assalamu alaikum and a very good day I bid to you, Dr. Sami Abdo. My name is Ahmad Muhsin bin Sazali, and I will be presenting to you my part, which is the results and also the observation. So let's first start with the results. So the part or the results are I will be showing you what we have obtained throughout the whole experiment. Now let's move on to the next slide. So, as you can see, there are three different pressure levels, which is 1.5, 3, and 6 bar absolute pressure for P4. If you look beside the pressure section, you can see that we ascertained the data for the ambient air for the three different pressure levels. After that, we recorded the data for the first stage of compression after 10 minutes. And 5 minutes after that, we got the second state of compression. And lastly, we obtained the data for the final compression. On to the next slide to see the rest of the table. As you can see, the final compression will be taken from the tank pressure all the way to the exchange water outlet. So the next part is the observation, which you will see how we got and obtained all the data in these two tables that I just showed you. On to the next part. Let's move on to the next part, that is observation. Now, before I go on and ramble about what we have observed during the experiment, let me just show you the whole setup of the two-stage air compressor experiment. Let's go to the next slide. So, this is the two-stage air compressor experiment setup. As you can see, at the part of the picture that is displaying number 1 is showing the cooling water flow rate. Number 2 is the flexible cable that will be plugged into diaphragm D1, D2, and D3, which is the part where it shows the number 3. Now that we kind of know most of the important parts, let's get into it. First, the thing that was observed was that it was made sure the cooling water flow rate was up to a 100 L over H, or liters per hour in this case, as you can see in the circle in the first picture. Next, in picture number 2, the blue flexible cable, which is shown by the green arrow, was plugged into diaphragm D1 with compressing air at P4 equals to 1.5 bar absolute pressure. When that's done, the main switch on the control panel was turned on and the small red lever, which is shown by the yellow arrow, was turned in order for the air pressure to enter. After that, in picture number 3, which is the panel where we can see all the readings for temperature and pressure, like, P0, P1, P2, P3, P4, etc., and also the T, we recorded the ambient air, which were T0 and P0. Then we had to wait for 10 minutes in order for us to take the readings for first state of compression, which were T1 and P1, by referring to the panel. When we're done with that, we waited for 5 minutes to take the reading for the second state compression, and then waited 5 more minutes to take the rest of the readings, which consist of T4, P3, T5, water circuit W1 and W2, air flow rate, input power T6, T7, T8, and lastly, the exchange water outlet T9. So the pressure we took from the P0, P1, P2, etc., and the temperature we got it from T, the part where it says T. Then we had to do all that again for diaphragm D2 at P4 equals to 3 and D3 at P4 equals to 6, and take the readings just the same. And that is it for observation. Let's move on to the next part.
So now I'm going to explain about this experimental theory. In figure 6.2 appendix A, filter free air into the first stage compressor air condition PODO. After the initial compression P1 T1, the air undergoes cooling in a heat exchanger before entering the second stage compressor air condition P1 T2. Subsequently, the final compressed air at elevated temperature P2 T3 undergoes additional cooling in a dual heat exchanger. Both heat exchangers use water as the cooling medium. And the cooling process also affects the temperature of the cooling medium T9. Thus, flow rate regulation during operation prevent unnecessary loss. So next I'm going to explain about the equation that we use in this experiment. Air compression is a polytropic process in form PV power of n equal to constant, where n is the polytropic coefficient, with the assumption that the actual air is considered an ideal gas with this characteristic equation PV over T equal to constant. Then we can obtain a good relationship between the temperatures and pressure or temperatures and volume for any point during the process as the follows. So in the below of the presentation or slide, that the equation that we use and we arrange and that we did.
Now, let's look at the calculation part. So for the calculations, it's just simple calculations which in the table it shows you how to calculate those values, which like for example the first state of compression, we have T1 minus T0, we have P1 minus P0, etc. And all of these calculations are even shown in the lab sheet. So most of them are simple calculations which we obtained easily.
Now I am Siti Fareha will continue to explain about the discussion part. So now let me continue by answering all the following questions related to the experiment that has been carried out. So for the first question, is an air compressor considered a closed or open system? So basically, an air compressor can be considered as closed system. As we understand in thermodynamics, a closed system is defined as a system that can exchange energy with its surrounding, but does not allow the transfer of matter across its boundaries. The air is compressed within this system and kept separate from the external environment. So we move to the second question, which is describe how a diaphragm works. So there are two stages that make the diaphragm work as shown. So what can I explain is at the stage 1, which is low pressure compression occur, air is compressed at low pressure in the first step. The upward motion raises the air pressure by reducing the volume of the chamber. And for the stage 2, which is high pressure compression occur, as the volume drops, the air pressure rises to a level much higher than in the first stage. For the third question, what is the heat exchangers function, and give an example of two industries that use the equipment. So basically, heat exchangers are primarily used to transfer heat from one medium to another without causing the two substances to mix. It makes it possible for thermal energy to be transferred effectively from one substance at a higher temperature to another at a lower one. Heat exchange devices are intended to increase the surface area contact between the two heat-producing compound procedure of transfer. Heat exchangers are widely used in two industries, which is HVAC and the chemical processing industry. So for the last question, how can we precisely measure the rotation speed of the motor? In a two-stage air compressor experiment, measuring the rotation speed of a motor called for specialized tools and techniques, including strobe light, photoelectric sensors, and tachometers. So that's all from me. Thank you.
Okay, next, my name is Syahirah Binti. Here I will explain about the conclusion and recommendation. Okay, so for the conclusion, in summary, the two-stage air compressor experiment demonstrated that the two-stage configuration offer improved efficiency and higher pressure ratios compared to a single-stage compressor. The inclusion of an interface stage effectively controlled the pressure during compression, addressing a common issue. The versatility of the two-stage design may explore for various applications, providing energy saving and adaptability. However, it is crucial to prioritize regular maintenance to ensure the continued reliability and longevity of the compressor. Overall, the experiment underscored the practical advantages of employing a two-stage air compressor in industrial setting. Alright, so for the last one is the recommendation. So for a smooth and accurate two-stage air compressor experiment, students should start by meticulously planning each step, ensuring a well-organized and anticipatory approach. Calibration of instrument is crucial for accurate measurement, and adherence to detailed standard operating procedure enhance the experimental reproducibility. Implementing data validation measures such as control experiment and cross-verification contribute to the reliability of the collected data. Prioritizing safety through strict adherence to safety protocol and guidelines create a secure working environment.
Now that we have reached the end point of our presentation about the two-stage air compressor, this is the end of our presentation. And with that, we thank you for your time and have a good one.